Right, hello. The rule at A-level is that you cannot take the log of a negative number. And this is quite topical actually, because there was a question on a recent A-level paper which essentially asked that. It was basically to do with the root of an equation. You had two roots and you had to say which one of these roots was not applicable. And the actual answer was that it was a negative number because you cannot take the log of a negative number. And a lot of people just made a real mess up of this. The most common error was to say that you cannot have a negative log, which is incorrect. You can have the logarithm of a positive number less than 1 is negative. But on the other hand, you cannot take the log of a negative number, which is the same thing. You cannot take the log of a negative number, which is a different thing. So, apart from that, just a lot of people had difficulty just writing a basic, unambiguous sentence in English. It was quite surprising, really. But yeah, at A-level standard, the rule is that you cannot take the log of a negative number. But actually, you can actually take the log. You can actually take the real logarithm. The natural logarithm of a negative number, and you can show it quite easily at A-level. It's not actually part of the A-level syllabus, but to actually prove to actually derive the natural log of a negative number is quite straightforward using the logic or the facts that you've learnt at A-level. So it's just A-level standard, really. And the trick is to go into the realms of complex numbers. So, say for example, I take -2. You have to realise that can be represented as a complex number. At a very basic level, it's -2 plus 0i as a complex number. That's not going to really help us a great deal. But you could also have another way of portraying it as actually the angle will be pi, I sine pi. You can represent it that way. Again, the modulus now is just +2, and the angle is pi. So you should know enough about complex numbers to realise where that pi comes from. Again, a more sophisticated way of representing that would be to say 2ei to the pi. And that's the reason I'm going through this in detail, is that representing a complex number in this form is actually quite useful. You come across questions where people would be better off representing a number in this form, but they're trying to play along with using this form, which gets a bit messy. So yeah, this is quite usually the most adaptable and flexible form to use for a complex number. So again, if I was to represent it on an Argand diagram, there's -2 here, okay? So it's got a modulus. It's on the real axis. It's got a modulus of 2 just from there to there, and the angle is pi. Okay, it's that angle gone from there to there. So that's why this is where this has come from. This angle here, pi. Right, so if I was to write that, what do they have in mind? At -2 equals 2ei pi. And that's really, with a bit of thought, you should be able to go from there to find out the natural log. It's very straightforward. I'll write ln, -2, natural log equals ln 2ei pi, which equals log 2 plus the log of ei pi, which equals log 2 plus I pi. So there you are. The natural log of -2 is the log of +2 plus I pi. So hopefully that's just fairly straightforward to understand, just using A-level logic to derive that. And I can generalise that now. that's just one angle, but I mean, looking at this, that's pi. I could go around another pi, couldn't I, to make it 3 pi, 5 pi, and so on. So that actually corresponds to an infinite number of logarithms. And then I can generalize yet again to a sort of just a general, finding the logarithm of a general complex number, you know, something like, I don't know, log of 3 plus 2i or something like that. Yeah. You should be happy at A-level standard. You should be happy with finding the modulus and the argument of that, and therefore you just apply the same logic again to find the logarithm of a general complex number. Right. Well, thanks if you're still with me, and all the best.